All right, let's now try to visualize a little bit of the big picture of this course, and then I'll also put that into the bigger context. I'll tell you what other constructs, what other concept will be covered in another course. Okay, other courses. Okay. Let's now look at this diagram here. I'm going to switch to my iPad just to make some annotations, but let's go bullet point by bullet point. So implementation will be built by reusable programming components. Take your earlier Java courses, for example, from your EECS 1021, 2030, and also 2011. Whenever you want to build some Java programs, you may just build everything from scratch by using the primitive array, or very often you might also want to use some Java library class, like a Java API, for example, array list, hash table, so you don't really have to reinvent everything from scratch, right? So that's why I said it's the programming components. So this is this part, library of programming components, okay? And this is something I would like to highlight first of all, okay? So this part here, you already know very well from the earlier course. So this part over here. So this is the part where your implementation, like a coding, will simply uses the library of programming component, like a Java API, right? So for example, using Java API, in which case you got an abundance of library classes for you to use, right? That's the first part. Okay, just about implementation. And for the implementation here, we're really talking about coding, right? Of course, that part of it could be maybe also to really run your Java code against maybe some JUnit test cases, just for correctness. That's also included, right? So we are now really separate implementation from testing in this diagram for simplicity, right? That's the first bullet point. And the second one, what's the goal? The goal is the implementation must satisfy the intended functionality that's in the requirements, right? So how do we see that in the diagram? It will be this part over here. Okay, so this part over here, you can see your implementation should satisfy all the requirements. And notice that I emphasize the requirements over here is informal over here, meaning that it may not be specified mathematically. Maybe just maybe it's only a written documents in English. Okay, so does it satisfy the informal requirements? Yeah, you can think about once you have done your implementation, does it really satisfy the informal requirements? So that's why I put the arrow over here. Does it satisfy? All right. And how can you check? Running JUnit tests will be one way to go. Or maybe you can have some peer review of your code, or maybe you simply deploy your system just for running and see if it ever run into crashes, right? There are different ways, but wouldn't it be nice if we can somehow formally justify whether or not your implementation satisfies the informal requirements and do it formally? Wouldn't that be nice? That's the purpose of this course. We'll get there. And then to really how do we really verify this particular system over here, right? This implementation, how do we verify that, right? You can think about this will be Java code, and this will be English. Okay, it's really important to see that the language for both worlds are different. So this will be typically natural language, like English. And this one over here, implementation or coding, this will be some programming language. Programming language. Apparently, natural language and programming language, they are not necessarily compatible. They're simply different languages. So communication between the two would be somehow not so smooth. How can you make sure one thing specified in one language will be consistent with another thing specified in a different language, right? That's really the inherent challenge of verification, right? So, by the way, so whenever you want to check to see whether your implementation satisfies the informal requirements, we are saying, did you build the product right? So this right over here is more like a adverb. We want to make sure the way we actually do it is actually correct, right? So what your implementation is actually correct. So now how can we solve the problem where the requirements and implementation are specified in different languages, are written in different languages? The idea would be we can do so-called formalization process. We can formalize the implementation into some formal language, and we can formalize the informal requirements into the same language. So now we will be able to communicate between the two after the formalization is done. Of course, how we can formalize both of them into the formal language, that's something we have to practice in this course. All right. Let's now go back to the slides. So, okay, let me just say one more thing here. We haven't finished yet. We formalize them. We formalize the informal requirements, and we formalize the implementation as a system model and a set of properties, right? So the code over here should be formalized as a system model by abstracting away irrelevant details. And also the informal requirements that specify in English that should be formalized as some system property, either healthiness property or safety property, as we mentioned in the earlier slides. All right. And then what kind of language, what kind of formal language should the system property and the system model be written in? The bottom line is this system property and this system model over here should be written, should be specified in the same language. Okay, it's really important to also notice that. Okay, system properties over here, and also system model, both of them should be specified using the same formal language. Otherwise, there's no point. Otherwise, there's no point of doing the formalization, because if they are different languages, then we are back to the same challenge where the natural language versus programming language, right? So specify using the same formal language. Okay, and in this course, we are going to use the language of a formal tool theorem prover called Rodin, which I'll briefly mention its name at the end of this current part of the module. And this current course, EECS3342, we're going to formalize the implementation into some system model into some theorem prover language. And similarly, we're gonna formalize the informal requirements as in English into the same theorem proving language, right? That's what we're gonna do. However, we're gonna learn about another formal method with a different formal language called model checker, and that's something you will learn about in the EECS3315, the subsequent course to the sequel to this course, which will be in your 4th year. All right, that's something you can look forward to as well. All right, so there will be two verification issues. One is, since you are trying to build the implementation based on the library, the Java API, for example, in that case, the Java API must be correctly implemented, right? That's straightforward. In this course, we don't really talk about how you can certify or prove the library components correctness, but the way to do it would be very similar to how we can prove that the implementation satisfies its informal requirements, but we don't really talk about this specifically. Okay, the number 2 is what we are going to focus on in this course. Okay, so we want to actually once we specify the two things over here in the same language, so now we can try to either check or prove whether or not the system model can satisfy the system property, right? So this is something, the proof is something that we have to do later in the course, right? We'll definitely get there. I'll give you the precise details as we get there. All right, and there's something very important here. All right, let's now talk about this. Here, let's say there's a very important question over here. Let's say you have done all the fantastic job of translating or formalizing informal requirements into system property, and also translating or formalizing implementation into system model, and also you have done some sound proof. Let's say you have done that. Does that really mean you have built the right products? It's a very fundamental question to ask yourself. Let me put it down here. success of the proofs means the right products is built. It's a very important question to ask. All right, over here. Not necessarily. Let me give you a simple example. Let's say this. Let's say somehow your system properties is simply about whether or not an array can be sorted in the non-descending order. And then your system model over here is simply maybe the abstraction of some sorting algorithm. Okay. However, the informal requirement itself may be just wrong in the first place, because maybe what the customer really likes is not to sort the array in the non-descending order. Maybe they want to sort it in the maybe non-ascending order, which is not exactly what you did, right? So there's some misunderstanding about how the informal requirement is formalized into the system property, right? So what I'm trying to say here is this part over here completely depends on this part being accurate and also being precise. If this part over here is not exactly what the customer, what your clients really want, in that case, it doesn't matter how fantastic job you have done over here, right? So that's the second concern. When you talk about whether or not the implementation satisfies the informal requirements, so that's about verification. Did we build the product right? There's another concern over here, which I'm going to talk about. Did we build the right products? It's really about asking whether or not this is actually accurate in the first place. Accurate. Is this really what we are supposed to build? It's a different question, right? Asking about whether or not this has been implemented in a way that satisfies this. It's a different question than whether or not this is actually accurate in the first place. Two different concerns. Okay? And so now I want you to really distinguish between, did we build the product right, where right is the adverb, and also did we build the right products, where right is the adjective, right? Hopefully you can see the difference between my use of language over here. Well, also it's a very common term for people to actually say. Let me talk a little bit more about it. So as I said, successfully proving your system model over here and over here doesn't really mean we have built the right products, because these informal requirements may just be misunderstood in the first place. Okay, so now the question is, how can we resolve this, right? So in that case, well, because the requirements inherently can be ambiguous, incomplete, and contradictory, because it's specified, written usually in the natural language. So that's why it can be easily misunderstood. So that's why, so there is a course later called EECS3342. So that's the requirements engineering course. So over there, you're going to learn about how you can write precise documentation that's free of ambiguity, incompleteness, or contradiction. So with how to really make sure this part over here is completely accurate and also free of these drawbacks is something you will learn beyond this course, maybe later in 4312. Maybe some of you are actually taking this course simultaneously, or maybe later. But anyway, keep in mind, right? In this course, we are only focusing on, did we actually build the product right? That's what we are focusing on in this course, right? And every time we talk about requirements, it's something that I will give to you, okay? Most of the cases.